Hi, I am Sharat Agarwal, a PhD candidate in IIIT Delhi. Will be presenting my work titled Reducing Annotation Effort by Identifying and Labeling Contextually Diverse Classes for Semantic Segmentation under Domain Shift. In training semantic segmentation model, one needs a lot of finely labeled data which is expensive to annotate and curate. So techniques like domain adaptation were introduced to mitigate data annotation cost by using synthetically generated data. Even after much research in supervised and semi-supervised domain adaptation, there is still a performance gap in comparison to a fully supervised model. So to maximize model performance with minimal labeling effort, recently active domain adaptation techniques have been proposed where the most informative samples from the unlabeled target domain are selected for the annotation. So there are two existing techniques for annotation. First, a frame-based, where entire selected frame is annotated, which leads to annotating redundant pixels, wasting annotation budget. Secondly, a region-based selects arbitrary region based on uncertainty in each image across the unlabeled pool, which are often tedious and challenging for a human to annotate. We hereby propose a novel and intuitive approach, a class-based annotation, where contextually relevant classes that are complementary for model training are identified in each actively selected frame, thus reducing the annotation effort and simultaneously increasing the model performance. We show that the set of hard classes are context dependent and typically vary across frames, and when annotated, help the model generalize better. For example, if a model has only seen straight roads for the road label, it will likely struggle in images containing road with turns, thus making road as a hard class in those frames. So here we discuss the overview of a proposed approach, namely anchor-based and augmentation-based. So given a small set of labeled target images X and an unlabeled image I, anchor-based and augmentation-based select classes to be labeled. In anchor-based, we compute class representative anchors which capture the class-specific confusion in the model predictions, which in turn helps in selecting the most informative classes in the selected pool. Anchor-based approach select class instances novel with respect to class-wise anchors chosen from the target dataset. This helps strengthen the per class representation in the feature space. Whereas in augmentation based, we measure the dissimilarity in the class confusions at inference time from strong and weakly augmented model. Augmentation based approach follows the self-supervised uncertainty estimation and chooses class instances based on the disagreement in the prediction probabilities for the corresponding weakly and strongly corrupted samples. Strong augmentations are intended to make the predictions harder, which helps in identifying classes which are more difficult for the model to learn. Here we can see that how the road regions frequently observed in the target domain remains unlabeled in the frame selected by anchor-based approach, but are labeled in augmentation-based approach due to the low confidence of the model. Here we show the comparison with domain adaptation techniques on GTF5 to cityscape settings. We can see that a proposed approach uses less data as compared to recent baselines. We compare with different active learning techniques. We observe significant improvement in MIU using our technique for all annotation budgets. To also understand the impact of frame selection strategy, we replace CDAL with other frame selection strategies like core set, MADA, and random selection. We observe significant improvement in performance using both our approaches for each of the frame selection strategies. Thank you.